Chapter 1: Why should you learn to write programs? Writing programs or programming is a very creative and rewarding activity. You can write programs for many reasons, ranging from making your living to solving a difficult data analysis problem to having fun to helping someone else solve a problem. This book assumes that everyone needs to know how to program, and that once you know how to program you will figure out what you want to do with your newfound skills. We are surrounded in our daily lives with computers ranging from laptops to cell phones. We can think of these computers as our personal assistants who can take care of many things on our behalf. The hardware in our current-day computers is essentially built to continuously ask us the question, "What would you like me to do next?" Right? Double quotation mark. Programmers add an operating system and a set of applications to the hardware, and we end up with a personal digital assistant that is quite helpful and capable of helping us do many different things. Our computers are fast and have vast amounts of memory and could be very helpful to us if we only knew the language to speak to explain to the computer what we would like it to do next. If we knew this language, we could tell the computer to do tasks on our behalf that were repetitive. Interestingly, the kinds of things computers can do best are often the kinds of things that we humans find boring and mind-numbing. For example, look at the first 3 paragraphs of this chapter and tell me the most commonly used word and how many times the word is used. While you were able to read and understand the words in a few seconds, counting them is almost painful because it is not the kind of problem that human minds are designed to solve. For a computer, the opposite is true. Reading and understanding text from a piece of paper is hard for a computer to do, but counting the words and telling you how many times the most used word was used is very easy for the computer. Python words py enter file, words txt to 16. Our personal information analysis assistant quickly told us that the word to was used 16 times in the first 3 paragraphs of this chapter. This very fact that computers are good at things that humans are not is why you need to become skilled at talking computer language. Once you learn this new language, you can delegate mundane tasks to your partner, the computer, leaving more time for you to do the things that you are uniquely suited for. You bring creativity, intuition, and inventiveness to this partnership. 1.1 Creativity and Motivation. While this book is not intended for professional programmers, professional programming can be a very rewarding job both financially and personally. Building useful, elegant, and clever programs for others to use is a very creative activity. Your computer or personal digital assistant PDA usually contains many different programs for many different groups of programmers, each competing for your attention and interest. They try their best to meet your needs and give you a great user experience in the process. In some situations, when you choose a piece of software, the programmers are directly compensated because of your choice. If we think of programs as the creative output of groups of programmers, perhaps the following figure is a more sensible version of our PDA. For now, our primary motivation is not to make money or please end users, but instead for us to be more productive in handling the data and information that we will encounter in our lives. When you first start, you will be both the programmer and the end user of your programs. As you gain skill as a programmer and programming feels more creative to you, your thoughts may turn toward developing programs for others. 1.2 Computer Hardware Architecture. Before we start learning the language we speak to give instructions to computers to develop software, we need to learn a small amount about how computers are built. If you were to take apart your computer or cell phone and look deep inside, you would find the following parts. The high-level definitions of these parts are as follows. The Central Processing Unit, or CPU, is the part of the computer that is built to be obsessed with what is next. If your computer is rated at 3.0 GHz, it means that the CPU will ask what next? 3 billion times per second. You are going to have to learn how to talk fast to keep up with the CPU. The main memory is used to store information that the CPU needs in a hurry. The main memory is nearly as fast as the CPU. but the information stored in the main memory vanishes when the computer is turned off. The secondary memory is also used to store information, but it is much slower than the main memory. The advantage of the secondary memory is that it can store information even when there is no power to the computer. Examples of secondary memory are disk drives or flash memory, typically found in USB sticks and portable music players. The input and output devices are simply our screen, keyboard, mouse, microphone, speaker, touchpad, etc. They are all of the ways we interact with the computer. These days, most computers also have a network connection to retrieve information over a network. We can think of the network as a very slow place to store and retrieve data that might not always be up. So in a sense, the network is a slower and at times unreliable form of secondary memory. While most of the detail of how these components work is best left to computer builders, it helps to have some terminology so we can talk about these different parts as we write our programs. As a programmer, your job is to use and orchestrate each of these resources to solve the problem that you need to solve and analyze the data you get from the solution. As a programmer, you will mostly be talking to the CPU and telling it what to do next. Sometimes you will tell the CPU to use the main memory, secondary memory, network, or the input-output devices. You need to be the person who answers the CPU's "what next?" question. But it would be very uncomfortable to shrink you down to 5 millimeters tall and insert you into the computer just so you could issue a command 3 billion times per second. So instead, you must write down your instructions in advance. We call these stored instructions a program. And the act of writing these instructions down and getting the instructions to be correct. Programming. 1.3 Understanding Programming. In the rest of this book, we will try to turn you into a person who is skilled in the art of programming. In the end, you will be a programmer. Perhaps not a professional programmer, but at least you will have the skills to look at a data information analysis problem and develop a program to solve the problem. In a sense, you need two skills to be a programmer. First, you need to know the programming language Python. You need to know the vocabulary and the grammar. You need to be able to spell the words in this new language properly and know how to construct well-formed sentences in this new language. Second, you need to tell a story. In writing a story, you combine words and sentences to convey an idea to the reader. There is a skill and art in constructing the story, and skill in story writing is improved by doing some writing and getting some feedback. In programming, our program is the story and the problem you are trying to solve is the idea. Once you learn one programming language such as Python, you will find it much easier to learn a second programming language such as JavaScript or C++. The new programming language has very different vocabulary and grammar, but the problem-solving skills will be the same across all programming languages. You will learn the vocabulary and sentences of Python pretty quickly. It will take longer for you to be able to write a coherent program to solve a brand new problem. We teach programming much like we teach writing. We start reading and explaining programs, then we write simple programs, and then we write increasingly complex programs over time. At some point you get your muse and see the patterns on your own and can see more naturally how to take a problem and write a program that solves that problem. And once you get to that point, programming becomes a very pleasant and creative process. We start with the vocabulary and structure of Python programs. Be patient as the simple examples remind you of when you started reading for the first time. 1.4 Words and sentences. Unlike human languages, the Python vocabulary is actually pretty small. We call this vocabulary the reserved words. These are words that have very special meaning to Python. When Python sees these words in a Python program, they have one and only one meaning to Python. Later, as you write programs, you will make up your own words that have meaning to you called variables. You will have great latitude in choosing your names for your variables, but you cannot use any of Python's reserved words as a name for a variable. When we train a dog, we use special words like sit, stay, and fetch. When you talk to a dog and don't use any of the reserved words, they just look at you with a quizzical look on their face until you say a reserved word. For example, if you say, "I wish more people would walk to improve their overall health," what? Walk. Blah 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 blah. That is because walk is a reserved word in dog language. Many might suggest that the language between humans and cats has no reserved words. 1. The reserved words in the language where humans talk to Python include the following. And L from not while as L if global or with assert else if pass yield break except import print class exec and raise continue finally is returned F for lambda try. That is it, and unlike a dog, Python is already completely trained. When you say try, Python will try every time you say it without fail. We will learn these reserved words and how they are used in good time, but for now we will focus on the Python equivalent of speak in human to dog language. The nice thing about telling Python to speak is that we can even tell it what to say by giving it a message in quotes. Print hello world. And we have even written our first syntactically correct Python sentence. Our sentence starts with the reserved word, print, followed by a string of text of our choosing enclosed in single quotes. 1.5 Conversing with Python. Now that we have a word and a simple sentence that we know in Python, we need to know how to start a conversation with Python to test our new language skills. Before you can converse with Python, you must first install the Python software on your computer and learn how to start Python on your computer. That is too much detail for this chapter, so I suggest that you consult www.pythonlearn.com, where I have detailed instructions and screencasts of setting up and starting Python on Macintosh and Windows systems. At some point, you will be in a terminal or command window and you will type Python. And the Python interpreter will start executing in interactive mode and appear somewhat as follows. Python 2, 6, 1 R261, 67515, June 24, 2020, 21 hours, 47 minutes, and 49 seconds GCC 4, 2, 1 Apple Incorporated. Build 5646 on Darwin. Type help copyright credits or a license for more information. The prompt is the Python interpreter's way of asking you, what do you want me to do next? Python is ready to have a conversation with you. All you have to know is how to speak the Python language. Let's say for example that you did not know even the simplest Python language words or sentences. You might want to use the standard line that astronauts use when they land on a faraway planet and try to speak with the inhabitants of the planet. I come in peace, please take me to your leader. File din and GT line 1. I come in peace, please take me to your leader. Cap syntax error. Invalid syntax. This is not going so well. Unless you think of something quickly, the inhabitants of the planet are likely to stab you with their spears, put you on a spit, roast you over a fire, and eat you for dinner. Luckily you brought a copy of this book on your travels, and you thumb to this very page and try again. Print hello world. Hello world. This is looking much better, so you try to communicate some more. Print you must be the legendary god that comes from the sky. You must be the legendary god that comes from the sky. Print we have been waiting for you for a long time. We have been waiting for you for a long time. Print our legend says you will be very tasty with mustard. Our legend says you will be very tasty with mustard. Print we will have a feast tonight unless you say file din and GT line 1. Print we will have a feast tonight unless you say cap syntax error. EOL while scanning string literal. The conversation was going so well for a while and then you made the tiniest mistake using the Python language and Python brought the spears back out. At this point, you should also realize that while Python is amazingly complex and powerful and very picky about the syntax you use to communicate with it, Python is not. Intelligent. You are really just having a conversation with yourself, but using proper syntax. In a sense, when you use a program written by someone else, the conversation is between you and those other programmers, with Python acting as an intermediary. Python is a way for the creators of programs to express how the conversation is supposed to proceed. And in just a few more chapters, you will be one of those programmers using Python to talk to the users of your program. Before we leave our first conversation with a Python interpreter, you should probably know the proper way to say goodbye when interacting with the inhabitants of Planet Python. Goodbye Trasabak most recent call last. File anlt din and gt line 1, in anlt module and gt name error. Name good is not defined. If you don't mind, I need to leave file anlt din and gt line 1. If you don't mind, I need to leave cap syntax error. Invalid syntax quit. You will notice that the error is different for the first two incorrect attempts. The second error is different because if is a reserved word and Python saw the reserved word and thought we were trying to say something but got the syntax of the sentence wrong. The proper way to say goodbye to Python is to enter quit at the interactive chevron prompt. It would have probably taken you quite a while to guess that one, so having a book handy probably will turn out to be helpful. 1.6 Terminology. Interpreter and compiler. Python is a high-level language intended to be relatively straightforward for humans to read and write and for computers to read and process. Other high-level languages include Java, C++, PHP, Ruby, BASIC, Perl, JavaScript, and many more. The actual hardware inside the central processing unit CPU does not understand any of these high-level languages. The CPU understands a language we call machine language. Machine language is very simple and frankly very tiresome to write because it is represented all in zeros and ones. 0 1 0 1 0 0 0 1 1 1 0 1 0 0 1 0 0 1 0 1 0 10 billion 1111 1 1 1 0 0 1 1 0 0 0 0 0 1 1 1 0 1 0 1 0 0 10 billion 101,101,101. Machine language seems quite simple on the surface, given that there are only zeros and ones, but its syntax is even more complex and far more intricate than Python. So very few programmers ever write machine language. Instead, we build various translators to allow programmers to write in high-level languages like Python or JavaScript, and these translators convert the programs to machine language for actual execution by the CPU. Since machine language is tied to the computer hardware, machine language is not portable across different types of hardware. Programs written in high-level languages can be moved between different computers by using a different interpreter on the new machine or recompiling the code to create a machine language version of the program for the new machine. These programming language translators fall into two general categories: 1 interpreters and 2 compilers. An interpreter reads the source code of the program as written by the programmer, parses the source code, and interprets the instructions on the fly. Python is an interpreter, and when we are running Python interactively, we can type a line of Python, a sentence, and Python processes it immediately and is ready for us to type another line of Python. Some of the lines of Python tell Python that you want it to remember some value for later. We need to pick a name for that value to be remembered, and we can use that symbolic name to retrieve the value later. We use the term variable to refer to the labels we use to refer to this store data. X equals 6 print x6, y equals x7 print y42. In this example, we ask Python to remember the value 6 and use the label x, so we can retrieve the value later. We verify that Python has actually remembered the value using print. Then we ask Python to retrieve x and multiply it by 7 and put the newly computed value in y. Then we ask Python to print out the value currently in Y. Even though we are typing these commands into Python one line at a time, Python is treating them as an ordered sequence of statements with later statements able to retrieve data created in earlier statements. We are writing our first simple paragraph with 4 sentences in a logical and meaningful order. It is the nature of an interpreter to be able to have an interactive conversation as shown above. Capital A. Compiler needs to be handed the entire program in a file, and then it runs a process to translate the high-level source code into machine language, and then the compiler puts the resulting machine language into a file for later execution. If you have a Windows system, often these executable machine language programs have a suffix of .exe or .dll, which stand for Executable and Dynamic Link Library respectively. In Linux and Macintosh, there is no suffix that uniquely marks a file as executable. If you were to open an executable file in a text editor, it would look completely crazy and be unreadable. Cap alpha a at b at c at a at 0x 82 dh4 at x 90 cap at 4 at g at $sign at f at 4 at 4x 80 dh 4x 80 dh 0 at 0 at e at d at c at ta at tx 81 dh tx 81 dhs at s at d at a at adhq vhtx 83 dhz 8. It is not easy to read or write machine language, so it is nice that we have interpreters and compilers that allow us to write in high-level languages like Python or C. Now at this point in our discussion of compilers and interpreters, you should be wondering a bit about the Python interpreter itself. What language is it written in? Is it written in a compiled language? When we type Python, what exactly is happening? The Python interpreter is written in a high-level language called C. You can look at the actual source code for the Python interpreter by going to www.python.org and working your way to their source code. So Python is a program itself, and it is compiled into machine code. When you installed Python on your computer or the vendor installed it, you copied a machine code copy of the translated Python program onto your system. In Windows, the executable machine code for Python itself is likely in a file with a name like C. Python 27 Python eggs. That is more than you really need to know to be a Python programmer, but sometimes it pays to answer those little nagging questions right at the beginning. 1.7 Writing a program. Typing commands into the Python interpreter is a great way to experiment with Python's features, but it is not recommended for solving more complex problems. When we want to write a program, we use a text editor to write the Python instructions into a file, which is called a script. By convention, Python scripts have names that end with .py. To execute the script, you have to tell the Python interpreter the name of the file. In a Unix or Windows command window, you would type Python hello py as follows: $cat hello py print hello world, $Python hello py hello world, $. The $$ is the operating system prompt, and the cat hello py is showing us that the file. We call the Python interpreter and tell it to read its source code from the file hello py instead of prompting us for lines of Python code interactively. You will notice that there was no need to have quit at the end of the Python program in the file. When Python is reading your source code from a file, it knows to stop when it reaches the end of the file. 1.8 What is a program? The definition of a program, at its most basic, is a sequence of Python statements that have been crafted to do something. Even our simple hello py script is a program. It is a one-line program and is not particularly useful, but in the strictest definition, it is a Python program. It might be easiest to understand what a program is by thinking about a problem that a program might be built to solve, and then looking at a program that would solve that problem. Let's say you are doing social computing research on Facebook posts and you are interested in the most frequently used word in a series of posts. You could print out the stream of Facebook posts and pore over the text looking for the most common word, but that would take a long time and be very mistake-prone. You would be smart to write a Python program to handle the task quickly and accurately so you can spend the weekend doing something fun. For example, look at the following text about a clown and a car. Look at the text and figure out the most common word and how many times it occurs. The clown ran after the car and the car ran into the tent and the tent fell down on the clown and the car. Then imagine that you are doing this task looking at millions of lines of text. Frankly, it would be quicker for you to learn Python and write a Python program to count the words than it would be to manually scan the words. The even better news is that I already came up with a simple program to find the most common word in a text file. I wrote it, tested it, and now I am giving it to you to use so you can save some time. Name equals raw input enter file. Handle equals open name, r text equals handle read words equals text split counts equals dict for word in words. Counts word equals counts get word, 0 plus 1 big count equals none big word equals none for word, count in counts items. If big count is none or count big count. Big word equals word big count equals count print big word, big count. You don't even need to know Python to use this program. You will need to get through chapter 10 of this book to fully understand the awesome Python techniques that were used to make the program. You are the end user, you simply use the program and marvel at its cleverness and how it saved you so much manual effort. You simply type the code into a file called words.py and run it, or you download the source code from http www.pythonlearn.com code and run it. This is a good example of how Python and the Python language are acting as an intermediary between you, the end user, and me, the programmer. Python is a way for us to exchange useful instruction sequences, that is, programs in a common language that can be used by anyone who installs Python on their computer. So neither of us are talking to Python. Instead, we are communicating with each other through Python. 1.9 The building blocks of programs. In the next few chapters, we will learn more about the vocabulary, sentence structure, paragraph structure, and story structure of Python. We will learn about the powerful capabilities of Python and how to compose those capabilities together to create useful programs. There are some low-level conceptual patterns that we use to construct programs. These constructs are not just for Python programs, they are part of every programming language from machine language up to the high-level languages. Input. Get data from the outside world. This might be reading data from a file, or even some kind of sensor like a microphone or GPS. In our initial programs, our input will come from the user typing data on the keyboard. Output. Display the results of the program on a screen or store them in a file, or perhaps write them to a device like a speaker to play music or speak text. Sequential execution. Perform statements one after another in the order they are encountered in the script. Conditional execution. Check for certain conditions and then execute or skip a sequence of statements. Repeated execution. Perform some set of statements repeatedly, usually with some variation. Reuse. Write a set of instructions once and give them a name, and then reuse those instructions as needed throughout your program. It sounds almost too simple to be true, and of course it is never so simple. It is like saying that walking is simply putting one foot in front of the other. The art of writing a program is composing and weaving these basic elements together many times over to produce something that is useful to its users. The word counting program above directly uses all of these patterns except for one. 1.10 What could possibly go wrong? As we saw in our earliest conversations with Python, We must communicate very precisely when we write Python code. The smallest deviation or mistake will cause Python to give up looking at your program. Beginning programmers often take the fact that Python leaves no room for errors as evidence that Python is mean, hateful, and cruel. While Python seems to like everyone else, Python knows them personally and holds a grudge against them. Because of this grudge, Python takes our perfectly written programs and rejects them as unfit just to torment us. Print hello world. File anlts din and gt line 1 print hello world. Cap syntax error. Invalid syntax print hello world file anlts din and gt line 1 print hello world cap syntax error. Invalid syntax I hate you Python. File anlts din and gt line 1 I hate you Python. Cap syntax error. Invalid syntax if you come out of there, I will teach you a lesson file anlts din and gt line. Invalid syntax. There is little to be gained by arguing with Python. It is just a tool. It has no emotions and it is happy and ready to serve you whenever you need it. Its error messages sound harsh, but they are just Python's call for help. It has looked at what you typed, and it simply cannot understand what you have entered. Python is much more like a dog, loving you unconditionally, having a few keywords that it understands, looking you with a sweet look on its face, and waiting for you to say something it understands. When Python says syntax error, invalid syntax, it is simply wagging its tail and saying, you seem to say something but I just don't understand what you meant, but please keep talking to me. Write double quotation mark. As your programs become increasingly sophisticated, you will encounter 3 general types of errors. Syntax errors. These are the first errors you will make and the easiest to fix. A syntax error means that you have violated the grammar rules of Python. Python does its best to point right at the line and character where it noticed it was confused. The only tricky bit of syntax errors is that sometimes the mistake that needs fixing is actually earlier in the program than where Python noticed it was confused. So the line and character that Python indicates in a syntax error may just be a starting point for your investigation. Logic errors. A logic error is when your program has good syntax but there is a mistake in the order of the statements or perhaps a mistake in how the statements relate to one another. A good example of a logic error might be, take a drink from your water bottle, put it in your backpack, walk to the library, and then put the top back on the bottle. Write double quotation mark. Semantic errors. A semantic error is when your description of the steps to take is syntactically perfect and in the right order, but there is simply a mistake in the program. The program is perfectly correct but it does not do what you intended for it to do. A simple example would be if you were giving a person directions to a restaurant and said, when you reach the intersection with the gas station, turn left and go 1 mile and the restaurant is a red building on your left. Your friend is very late and calls you to tell you that they are on a farm and walking around behind a barn, with no sign of a restaurant. Then you say, did you turn left or right at the gas station? And they say, I followed your directions perfectly, I have them written down, it says turn left and go 1 mile at the gas station. Then you say, I am very sorry, because while my instructions were syntactically correct, they sadly contained a small but undetected semantic error. Again, in all 3 types of errors, Python is merely trying its hardest to do exactly what you have asked. 1.11 The Learning Journey. As you progress through the rest of the book, don't be afraid if the concepts don't seem to fit together well the first time. When you were learning to speak, it was not a problem for your first few years that you just made cute gurgling noises. And it was okay if it took 6 months for you to move from simple vocabulary to simple sentences and took 5 to 6 more years to move from sentences to paragraphs, and a few more years to be able to write an interesting complete short story on your own. We want you to learn Python much more rapidly, so we teach it all at the same time over the next few chapters. But it is like learning a new language that takes time to absorb and understand before it feels natural. That leads to some confusion as we visit and revisit topics to try to get you to see the big picture while we are defining the tiny fragments that make up that big picture. While the book is written linearly, and if you are taking a course it will progress in a linear fashion, don't hesitate to be very non-linear in how you approach the material. Look forwards and backwards and read with a light touch. By skimming more advanced material without fully understanding the details, you can get a better understanding of the why of programming. By reviewing previous material and even redoing earlier exercises, you will realize that you actually learned a lot of material even if the material you are currently staring at seems a bit impenetrable. Usually when you are learning your first programming language, there are a few wonderful aha moments where you can look up from pounding away at some rock with a hammer and chisel and step away and see that you are indeed building a beautiful sculpture. If something seems particularly hard, there is usually no value in staying up all night and staring at it. Take a break, take a nap, have a snack, explain what you are having a problem with to someone or perhaps your dog, and then come back to it with fresh eyes. I assure you that once you learn the programming concepts in the book you will look back and see that it was all really easy and elegant and it simply took you a bit of time to absorb it. 1.12 Glossary. Bug. An error in a program. Central Processing Unit. The heart of any computer. It is what runs the software that we write, also called CPU or the processor. Compile. To translate a program written in a high-level language into a low-level language all at once, in preparation for later execution. High-level language. A programming language like Python that is designed to be easy for humans to read and write. Interactive mode. A way of using the Python interpreter by typing commands and expressions at the prompt. Interpret. To execute a program in a high-level language by translating it one line at a time. Low-level language. A programming language that is designed to be easy for a computer to execute, also called machine code or assembly language. Machine code. The lowest level language for software, which is the language that is directly executed by the Central Processing Unit CPU. Main memory. Stores programs and data. Main memory loses its information when the power is turned off. Parse. To examine a program and analyze the syntactic structure. Portability. A property of a program that can run on more than one kind of computer. Print statement. An instruction that causes the Python interpreter to display a value on the screen. Problem solving. The process of formulating a problem, finding a solution, and expressing the solution. Program. A set of instructions that specifies a computation. Prompt. When a program displays a message and pauses for the user to type some input to the program. Secondary memory. Stores programs and data and retains its information even when the power is turned off. Generally slower than main memory. Examples of secondary memory include disk drives and flash memory and USB sticks. Semantics. The meaning of a program. Semantic error. An error in a program that makes it do something other than what the programmer intended. Source code. A program in a high-level language. 1.13 Exercises. Exercise 1. What is the function of the secondary memory in a computer? A. Execute all of the computation and logic of the program. B. Retrieve web pages over the internet. C. Store information for the long term even beyond a power cycle. D. Take input from the user. Exercise 2. What is a program? Exercise 3. What is the difference between a compiler and an interpreter? Exercise 4. Which of the following contains machine code? A. The Python interpreter. B. The keyboard. C. Python source file. D. A word processing document. Exercise 5. What is wrong with the following code? Print hello world. File din and GT line 1 print hello world. Cap syntax error. Invalid syntax. Exercise 6. where in the computer is a variable such as x stored after the following Python line finishes. X equals 123. A central processing unit. B main memory. C secondary memory. D input devices. E output devices. Exercise 7. What will the following program print out? X equals 43. X equals x plus 1. Print x. A 43. B 44. C x plus 1. D error because x equals x plus 1 is not possible mathematically. Exercise 8. Explain each of the following using an example of a human capability. 1 central processing unit, 2 main memory, 3 secondary memory, 4 input device, and 5 output device. For example, what is the human equivalent to a central processing unit? Exercise 9. How do you fix a syntax error? 1. HTTP. xkcd.com/231.